So here is our unit circle, and we are supposing that we have a terminal point that's determined by the angle t on the unit circle, and then we want to find the terminal point that is determined by these angles. So they'll be related to this. This is our given terminal point, 1/3 2 root 2 over 3. These are all of the standard angles on the unit circle and their coordinates. So for this one, we'd go 1/3 to the right and 2 root 2 over 3 up. So 1/3 to the right would be about right here, and then we'd go up from there. So that is our given point. So this right here is 1/3 2 root 2 over 3. And that is a quadrant 1 point. Now, every point on the unit circle is related to 3 other points on the unit circle by reflections here. So let's do some reflections. I'll do this in blue. So if we reflect down, straight down here, that a little bit bigger. Or if we reflect across from that point here, or across from the reflected point, so basically you make a rectangle. Then we get 3 other points with the same coordinates, except maybe some negatives and positives. So this point right here, the x is negative, but the y is positive. So that is going to be negative 1/3 2 root 2 over 3. This guy down here, both the x and y are negative because you go left and then down. So that's going to be the point negative 1/3 negative 2 root 2 over 3. And then this one right here, we've got a positive x and a negative y to get to that one. So this one has the negative. So for this type of problem, you just want to sketch that box and then put the coordinates on those points. Okay, so our angle t is, the terminal point determined by t is right there. That means that this angle t is right here. So t radians there. So then they ask us, well, what about negative t? So positive angles are counterclockwise, negative angles are clockwise. So if we go clockwise the same amount here, that's going to be minus t. And you can see that that is going to determine this point down here. So that's going to be our answer for part A. So we just change the y to a negative. So right there. 6 pi plus t. Okay, so t starts right here, and then 6 pi is 3 times 2 pi. That's 3 revolutions. So we're going to go t, and then we're going to go plus 2 pi. So we're going to go here, and we're going to go plus 2 pi, plus 4 pi, plus 6 pi. And that's going to end us at that same angle, t. At least they're coterminal. They end at the same place. So it's just that point we started with, 1/3 and 2 root 2 over 3. So let me get that messy out of there. So this one is the same as the starting point. And that'll work for any even multiple of pi. Pi minus t. Okay, so pi is 180 degrees. So this is t, and then pi is over here. So pi is 180. And then if we subtract off t, what's left over, which is this right here, that's going to be pi minus t. Okay, except we're having this start from the positive x-axis. and not the negative x-axis. So, pi minus t here, let me get rid of this and this. Okay, so this angle here, that's pi minus t, that amount of rotation, except we're starting at the positive x-axis. So if the pi minus t is on the left, it leaves t on the right. So if we put the pi minus t on the right here, it's going to leave t on the left. So pi minus t here, and that is going to be this terminal point. And then we're going to have t left right here, t radians. Because pi minus t plus t has to make up pi, which is halfway around the circle, 180 degrees. So now we're using this terminal point for pi minus t. So let's bring that guy down. And then what about t minus pi? Okay, so t subtract off 180 degrees. So this is saying start at t here, which is this angle right here. So we're going up there. But then we're going to subtract 180 degrees. So negative angles go counterclockwise. 180 degrees is halfway around the circle. So we are going to, let me use a different color here. We're going to turn back around here and go 180 degrees halfway around the circle in the opposite direction. So that's going to land us on this point right here, where both coordinates were negative. Negative 1/3 and negative 2 root 2 over 3. So this one will be negative 1/3, negative 2 root 2 over 3. And then one more, 2 pi minus t. Well, 2 pi is just one revolution and starts you at 0. So 2 pi is coterminal with 0. 2 pi minus t is going to be equivalent to just minus t. Because 2 pi ends the same place 0 is. It's like 0 minus t. And minus t gave us this one. So this is going to be the point 1/3 negative 2 root 2 over 3. Again. So hopefully that gives you some insight into how to do similar problems in WebAssign.